Okay, so we're looking at balancing equations, right? So your typical chemical equation looks like this, right? The reactant represented by R, right? R, then in brackets reactant. That means reactant. R means reactant. Plus R, which is reactant, right? Is equal to the product, which is represented by P. So that's your typical chemical equation. So let me take you to the periodic table really quickly, right? So hold on, I pre-did all this on like one page, so I didn't have to do too much. So H, we're gonna represent everything to do with hydrogen in blue, right? And we're gonna represent everything to do with oxygen in purple. Remember, I pre-did a lot of these notes, so color coding doesn't really work because together H2O water molecules we're representing in red. So hydrogen naturally occurs in the atmosphere as H2, oxygen naturally occurs in the atmosphere as O2, and water and that is H2O. We know the chemical formula is H2O. So back to the equation, R plus R is P. Reactant plus reactant is product, right? So in this case, hydrogen, reactant, plus oxygen, reactant is water, right? Hydrogen, blue, oxygen, purple, water, red, right? H2 plus O2 is H2O. I wrote it in I missed H2O, right? I missed the O. But that's how you'll see it's typically written in chemical equations that you're given, right? And this is obviously a very basic chemical equation. I'm just giving you an idea of how it works. So, right, we're going to start off by looking at O2, right? There's one oxygen in H2O. So, we're going to divide into. So cancel the 2 because there's only one left on this side because one of them is transferred to the right-hand side, right? We're just dividing the left-hand side by the right-hand side. So H2, both are represented on the right-hand side in H2O. But we are here to balance the equations, right? So there has to be an equal amount of elements in the right-hand side as the left-hand side. So as you can see, oxygen, there's one extra, and we don't want that. Balancing, when dividing the elements, they should equal 0, right? So what we're going to do is rewrite the equation, but give an additional H2 group because we want to have the option to make more H2O so that all oxygen molecules can be used, right? So H2O, there are always going to be more hydrogens than oxygens. So if you want more H2O, you supply more hydrogens so we can use all the oxygens. So 2H2, 2 groups of H2, right, plus O2, right, equals H2O, right? So that's the theory of it. And then let's see if it stacks up, right? So when typically balancing, we're going to do what we did again, cancel out, right? So H2, one of them is represented there, right? H2 is cancelled. So, the 2 is cancelled. So we have one H2 left to deal with, right? Because the 1 is fully represented there. O2, right, is 1 oxygen is used. So we cancel the 2, right? And then oxygen, the one we there's an oxygen represented on the right-hand side. So we've got an additional H2 and an O ready to be used, which can make another water molecule, right? And so that's exactly what we wanted, because it means both on the right-hand side and on the left-hand side, there's going to be nothing left if you divide them into each other, right? So it makes 2 H2O. Yeah. Both H2s are cancelled out, or represented on both the left and the right. And then the O2 is represented in the left and the right, both oxygen, right? Because the 2 before the formula means everything in the equation is times 2. In the formula, chemical formula is times 2, right? So we're going to move. So that's, balancing equations. That's balancing equations. Making sure the left-hand side and the right-hand side are properly represented, because in chemical reactions, no side disappears. No elements disappear. Right? So that's balancing equations. So this is a voiceover. I screen recorded myself, doing the teaching part of it, and then went to CapCut and voiced over. And so I'm getting out a balancing equations worksheet. And so I'll be going slowly at first, so you get the gist of it. And I'll pick up speed a bit later into it. So if it feels a bit slow at first, it's just to make sure I really explain it thoroughly. I'm sorry I took long. I started yesterday, because I'm going to send it. Today is Wednesday. I'm going to send it today. I started yesterday, and then I got busy, and then I got unbusy late, and then I half forgot, but we're good. So here's the worksheet. And so, chemical equations to balance. O2 and H3 equal HNO3 plus H2O, right? Or O2 plus NH3, or yada, yada, yada. Okay, let's zoom in real quick. Okay, so these gaps, the spaces, are where we're going to fill in our numbers for balancing the equations. So O3, there are 3 oxygen molecules there, right? Plus another O, this is on the right-hand side, obviously, there's 1 oxygen molecule there. So together, there are 4 oxygen molecules represented on the right-hand side of the equation. And like we said, they have to be equal on the left and right-hand sides. So O2, there's 2 of them, right? And so, obviously, doing quick maths, 2O2 is equal to 4, right? So let me rub this out quickly. Yeah. Okay, this is going to get a bit messy, but the next one will be more clear. So, nitrogen, there's 1 nitrogen over here on the right-hand side, right? And over here, hydrogen, right? Still on the right-hand side. There are 2 hydrogens over here, and 1 hydrogen and HNO3. So 2 plus 1, right? They're 3 altogether hydrogens on the right-hand side, and 1 nitrogen on the right-hand side. So let's going back to the left. There are 3 hydrogens on the left-hand side, and 1 nitrogen on the right-hand side, and the left-hand side. So they balance out. So Usually you're going to leave the places blank, but I'm going to write 1 to show that it's unchanging. It's just 1 that's being used. But yeah, I'm writing 1 for the worksheet, but usually you'll leave it blank to show that, you're not doing any editations to the amount of molecules of something that they're going to be in the formula, or in the equation rather. So we've done the rubbing out. Next question. So looking at, they're less on the left than the right, so you're going to write 2 on the right, but that would just make 6 oxygen molecules, and 2 times 3 is 6. So just basic math. This one is a very easy question. 3 on the left, 2 on the right. It will balance out to 6 molecules on both sides, right? Okay, here there are 2 hydrogens on the left-hand side, right? And then 2 hydrogens on the right-hand side, plus no more hydrogens on the right-hand side. So 2 hydrogens on both sides, it balances out, right? So we're gonna put a tick there. It balances out. Hydrogens are evenly distributed, right? And then the oxygen, right? There are 2 oxygens over here on the left-hand side. Oh, I've made a mistake. Hold on. On the right-hand side, over here, there's 1 oxygen, right? And 2 oxygens, making 3 altogether. And as we know, no atoms or elements disappear, so this can't work, right? And no atoms or elements are magically added in secret steps, right? Chemical reaction is just a change of the positions of atoms and combinations of atoms in an equation, right? There can't be any extra or any lesser. So we added 2 to this molecule. So this will give us 4 hydrogens on the left side. So we obviously have to do the same thing on the right side, so the hydrogens can remain balanced, right? So 4 hydrogens on the right side. So that checks out. 4 on the left, 4 on the right. None disappeared, none were added, right? And so, let me quickly rub this out and then redo what we did to 2, right? So, O2, 2 O2, so there are 4 of them, right? 4 oxygen atoms. Same thing here, right? 2 O's, that's 2 oxygen, plus O2, that's 2 oxygen, which leaves 4 oxygen atoms. Bada bing, bada bang, it balances, right? So that's how we're gonna write it. Sorry, I had to rub it out to remove the circles and everything, but we got it. 2H2O2 is equal to 2H2O plus 1O2. But like I said previously, you won't have to write the 1 when you're actually balancing equations, because O2 is already 1O2. So here, let's look. I believe this is rubidium. There's 1 on the left and 1 on the right. It balances, right? So we're going to look at hydrogen now. So let's see, H2, there are 2 of them. Let me rewrite, there are 2 of them, right? On the left. On the right, there's 1 hydrogen here, and then there's an H2 here. So there are 3 hydrogen atoms in this equation, or on the right side of this equation. And these don't balance. 2 and 3 are not the same, right? Before we work out balancing that, let's look at oxygen. So there's one oxygen on the left-hand side, right? One oxygen on the right-hand side. It balances. So it's only hydrogen we have to focus on right now. My bad, let me quickly, okay. So rub this all out. So we're gonna add more hydrogen to the left-hand side because they're less than on the right-hand side. And like we know, we need it to balance. So 2H2O, that makes 4 hydrogens on the left-hand side, right? And then check over here, we've got H, 1H over here, and 2H over here, which, 1 plus 2 is 3. So 4 on the left, 3 on the right, it doesn't balance either, so we have to add to the right-hand side. So I'm adding 2 to RBOH, right? So that gives us 2 oxygens here, meaning they're 4 altogether, right? So that now balances, right? However, the RB was changed on the right-hand side. There are now 2 of them there, and there's an extra oxygen. So we need to balance it on the left-hand side. So we're gonna add 2 to RB because there's a 1 on the left and 2 on the right, right? So we're gonna add a 2 to RB to make it 2 on the left and 2 on the right. It balances. And then O2, there are 2 oxygens here. Well, it's not O2, there's 2 oxygens, 2 H2O molecules, so 2 oxygens, right? Because we added a 2 to H2O because that's the only place where hydrogen is represented on the left-hand side. So there are 2 oxygens on the left-hand side and 2 oxygens on the right-hand side because we, balanced it out. So 2, 2, 2 plus 1 hydrogen molecule, right? I'm just showing you again the 2 oxygen here and 2 oxygens here. It balances, right? And we already did the same for, I believe it's rubidium and for hydrogen, right? So the whole equation balances. We don't have to make a change to H2, right? So that's the premise of balancing equations. If you need to watch this again and again to get it, I encourage you to do so. You can never dedicate too much time to understanding a concept fully, right? So ignore what's going on the screen. I already showed you this. It had slipped my mind that I already balanced the hydrogens. So I was redoing it on screen, right? So next question. Chlorine, 2 chlorine atoms, 1 on the left, 1 chlorine atom on the right. It does not balance, right? So, let's see K, which is potassium, right? Let's see potassium. 1 potassium on the left, 1 on the right. It balances, right? So let's check out bromine, right? So 1 bromine on the left over here, and then 2 bromide atoms on the right. So it doesn't balance, right? So what we're gonna do is add a 2 before potassium chloride and a 2 before potassium bromide, right? Because there are 2 chlorine on the left and 1 on the right, 2 bromine on the right and 1 on the left. So we're adding 2 to each side so that it balances. We're adding 1 to each side so that it balances, right? So 2 chlorine counted on the left and 2 chlorine counted on the right. That balances. It checks out. Now let's check potassium, I believe. Right, so let's rub this out. So there's 2 potassium over here, right, on the left-hand side, and 2 potassium on the right-hand side. It balances. Yeah, let's go. Right? So, let me quickly rub that out. Right? So, let me rewrite that too quickly. Yeah. So, now we're checking bromine. The 2 bromine over here on the left and 2 bromine on the right. So that bada bing, bada boom, bada balances. Let's go. Right? So I feel I hope you're getting the gist of it, right? I hope you're getting like a little bit of clarity around it now. So let's go to the next question, right? Nitrogen gas plus hydrogen gas is equal to ammonia, right? A very common reaction you're gonna come across in chemistry. So, I did this one really quickly, right? There's less hydrogen on the left-hand side than the right-hand side, right? And there's less nitrogen on the right-hand side than the left-hand side. So add 2 to the right-hand side, and you automatically know there's 6 hydrogen, right? 2 times 3 is 6. So you add 3 to the hydrogen and nothing to the nitrogen, right? Like I said, I'd go fast at later stages, right? This is later stages. So just a bit of quick mental maths, because you understand that the left and right have to balance. So, yeah. I'm gonna give you the rest to do. So, I've got the answers with me. You can do them. You can do it on your phone, or you can do it in a workbook and take a picture, whatever works for you. And then send to me, I'll mark it, and we'll see if there's any need to go over it again. Yeah.